Today I'm going to talk about how to get equations from other types of functions like lines and graphs. We'll also talk about how to find them from tables. So when it comes to a linear function, like this one here, we know that they follow a very typical pattern of something like this. Y equals mx plus b. This is slope-intercept form. And we know that the m stands for the slope, and the b represents the y-intercept. So we can go ahead and figure out where the line crosses the y-axis, and we know that that's the y-intercept. So in this case, it'll be -2. From there, we can simply count up to the next point that meets at a nice grid mark, like this one does, which is this point right up here. On the other lines, it might be different. And you can count and figure out what it will be. Remember that slope is the same thing as the rate of change. Which is also just the same thing as the rise over the run. So in this case, let's figure out what a rise is. 1, 2, 3, 4, 5 up. And we're going 1, 2, 3, 4 to the left, which in this case is the negative direction. So we have -5/4 for our slope. So if we put the pieces together, we get y equals -5/4 x minus 2 for the answer to the equation of this line. Now, when it comes to a table like this, we can kind of do the same thing. You could go through, you could plot all these points and figure out all of the different, what's the right word? All the different things kind of like this and connect the dots. You could do that. Today I'm going to show you how to do that algebraically. So first, just recall that we could rewrite these points like this. 1, -13, 4, -11, 7, -9, 10, -7, 13, -5, and so on and so forth. All right? And so from here, to figure out what the rate of change would be, we would keep in mind that since it's a line, it's going to be the exact same for all points in the line. So we can pick any of these points here to do. I'm going to pick the top two, but like I said, you could pick any of them. All right? From here, we have to remember the slope formula. Which is y2 minus y1 over x2 minus x1. That should look familiar too, because that's just the same thing as what we did up here. We figured out the change in the y direction, and then we figured out the change in the x direction. We're doing the exact same thing here. So let's go ahead and declare one of the points, the first point, and one of the points, the second point. All right. From there, we just plug in our numbers. -11 minus 13. It's a -13 over 4 minus 1. We get 2 over 3. Cool. There's our slope. Now what do we do? Well, you could plug your slope into y equals mx plus b, then pick an x and y from one of your points and plug it in and solve for b. Or you could use a different form of the line called point slope form. Point slope form, it's a different way to figure out what a line would be. It's very similar to things that we've done before, like slope-intercept form and standard form, only this one gives you a point and it gives you the slope. The generic form looks like this. Y minus y1 is equal to mx minus x1. Now this, I get that it looks kind of confusing because you have an extra y1 and an extra x1 compared to just the y and the x. But it's really not that bad once you realize that the x1 and the y1 are the same as the numbers that you used over here. You just get to plug them into this formula. So let's go ahead and do that. It's going to be y minus negative 13 is equal to 2/3, that's our slope, x minus 1. And I'm just going to go ahead and simplify that a little bit. Oops. Y plus 13 is equal to 2/3 x minus 1, parentheses. All right, that's kind of the idea for today.